Hello folks, this is Minless Coding. Today we are going to study a bit Azure Authentication and Authorization. I've got some feedbacks about the visibility, or I would say the display, the text visibility. Yeah, I heard that texts are a bit small for maybe the mobile users, mobile device users. So I'm making it a bit bigger now, only for you guys. Let's see. If this is going to fix your issues. Yeah, a lot of people are talking about my channel and how awesome it is and stuff like that, but I don't care too much about these discussions, because I do my job, and if I'm good at it, of course the compliments will follow. Yeah, let's start. Enough talking. Explore Microsoft Identity Platform. Microsoft Identity Platform helps you build applications your users and customers can sign into using Microsoft Identity. Social accounts provide authorized access to your own API or Microsoft APIs. There are several components that make Microsoft Identity Platform. OAuth 2.0 and OpenID Connect standard compliant authentication service, enabling developers to authenticate several identity types, including work account provision through Microsoft Entra, personal Microsoft account, social accounts like Azure. Social or local accounts. Social or local customer accounts by using Entra external ID. Interesting. Open source libraries. Microsoft Authentication libraries, MASL, then support for other platforms compliant libraries. There are several components that make up the Microsoft Identity Platform. Okay. Consists of those components. Then the first thing is then the standard compliant authentication service, enabling developers to authenticate several identity types. Auth 2, OpenID, open source libraries. Microsoft Identity Platform endpoint works with the Microsoft Authentication libraries. Application management portal. Okay, registration and configuration experience in the portal, along with application configuration API and PowerShell programmatic config of your application through blah blah. You can automate your DevOps tasks. For developers, the Microsoft Identity Platform offers integration of modern innovations in the identity security. Blah 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 blah. You need to implement such functionality yourself. Applications integrated with Microsoft Identity Platform natively take advantage of such innovation. Okay. I'm excited. Let's see this one. To delegate identity and access management functionality to Enter ID, an application must be registered with the Enter tenant. When you register your application with the Entra, you are creating an identity configuration for your application and allow it to integrate with the Entra. When you register an app in the portal, you choose whether it is single tenant, multi-tenant. If you register an application in the portal, an application object, the global unique instance of the app and the service principal object are automatically created. If you know me, also you know that I am taking notes. I will start taking notes then. Service principals. Single tenant, multi-tenant, only accessible in your tenants. Multi-tenant, accessible in other tenants. And register an application in the portal. Application object and the service principal object automatically created. Yes. In the portal you can then add secret certificates, your app customize branding, blah 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 blah. You can also create service principals object in a tenant using PowerShell, CLI, Graph, and other tools. Microsoft Graph. Other tools such as PSAP, ARM template, Terraform, or Pulumi. Application object scoped. Entra application is scoped to its one and only application object. The application object resides in the Entra tenant where application was registered. An application object is used as a template or blueprint to create one or more service principal objects. A service principal is created in every tenant where the application is used. Okay. The service principal is the enterprise application side, probably. Then the app registration is the application object. This is the application object. But in each tenant there is another resource is being created, which is the enterprise application. If you see in the portal, it's named enterprise applications, but it corresponds to service principal here. Also, you can also call it service principal. Is created in every tenant where application is used, similar to a class in object-oriented programming. The application object has some static properties well defined that are applied to all created service principals. Very good defined, explained. The application object describes three aspects of an application. Okay, how the service can issue tokens in order to access the application. Okay, resources that the application might need to access. Okay, the permission side maybe. The actions that the application can take. This is the permission side. This is the might need to access. Maybe the secrets and certificates then. Graph application that defines the schema for application objects property. Service principal object. Service principal object. To access resources secured by Microsoft Entra, the entity that is requesting access must be represented by a security principal. This is true for both users and applications. 1 second. That's true. Secure service principle defines access policy, permissions, access policies, and permissions for user/application in the end-to-end. This enables core features such as authentication of the user application during sign-in, authorization during resource access. There are three types of service principles: application, managed identity, legacy. Okay. This type of service principle is the local representation of application instance of a global application object in a single directory. A service principle is created in each tenant where the application is used and the references the globally unique object. The service principle object defines what the app can actually do in the specific tenant, who can access the app, and what resources the app can access. Okay. The managed identity. This type of service principle is used to represent a managed identity. Managed identities provide an identity for applications to use when connecting to resources that support Microsoft Entra authentication. When a managed identity is enabled, service principle representing that managed identity is created in your tenants. Service principles representing managed identities can be granted access and permissions, but cannot be updated or modified directly. Three service principles that represents application, represents identity. Okay, but the application is also an identity. App registration, right? App registration is also an identity, which is a manual identity, but okay, there's another identity for the managed identity. So another service principle or another enterprise app. Good. Legacy. This is important, I think. Three type of app registrations. Service principles. Application. Application. Managed identity. Legacy. What is this type of service principle? Represents a legacy app, which is an app created before app registrations were introduced or created through legacy experiences. Okay, legacy service principle can have credentials. Credentials. Service principle names. Reply URLs and the other property that an authorized user can edit but doesn't have a associated app registration. I got it. The version of where you are able where the version of combination of app registration and service principle. The relationship between, let's take the note here, app plus enterprise. Okay. Relationship between application object and service principles. The application object is the global representation of your application for use across all tenants, and the service principle is the local representation for use in a specific tenant. The application object serves as a temple from which common and default properties are driven for use in creating responding service principal objects. An application object has a one-to-one relationship with the software application. Yeah, that's true. One-to-many relationship with its corresponding service principal objects. Okay, understandable. A service principal must be created in each tenant where the application is used to establish an identity for signing or access to resources being secured by tenant. A single tenant application has only one service principal in its home tenant, created and consented for use during app registration. The multi-tenant application also has a service principal created in each tenant where a user from that tenant consented to its use. Okay, let me explain the purposes of the app registration and service principal. The app registration, as it says, it's only one for the application. It represents the application actually. Then there are some configurations on it. You can adjust related with the login, how the login is going to be, the login flow. Yeah, you define the login flow. There are some parameters, callback URLs, and the permissions, the API permissions. You consent the API permissions, or they will define the API permission, the application use, right? Then you kind of define which APIs or which information the user, the application will ask from the user, and the secrets, certificates, right? Yeah. And what else? The client ID is there. Yeah, on the other hand, the service principal side is more about who has access, who can access to this application, you see, because you have users in your tenants or in other tenants, right? There are multiple users. Then you can give access or deny access to that some users, so some group of users maybe. Yeah, then not everybody can use the application. Maybe more, yeah. We are going to learn. Discover permissions and consent. Exactly. This is what we need. Applications that integrate with the Microsoft Identity and Platform follow an authorization model that gives users and administrators control over how the data can be accessed. Microsoft Identity Platform implements O2 authorization protocol. OAuth is a method through which a third-party app can access web-hosted resources on behalf of a user. On behalf of a user. This is important, okay? And any web-hosted resource then integrates with the Microsoft Identity Platform has a resource identifier or application ID URL. There are some examples of Microsoft web hosted resources. Microsoft Graph, yeah. Microsoft 365 Mail API, some examples, okay, yeah. The same is true for any third-party resources. The same is true for third-party resources that are integrated with the Microsoft Identity Platform. Any of these resources also can define a set of permissions that can be used to divide the functionality of that resource into smaller chunks. When a user's functionality is chunked into small permission sets, okay, third-party apps can be built to request only the permissions that they need to perform their function. Users and administrators can know what data the app can access. In Auth 2, this type of permission sets are called scopes. Yeah, okay. They are often referred to as permissions. In the Microsoft Identity Platform, a permission is represented as a string value. An app request permissions it needs by specifying the permission in the scope query parameter. Identity Platform supports several well-defined OpenID Connect scopes and resource-based permissions. Each permission is indicated by appending the permission value to the resources identifier or application URI. For example, the permission string graph Microsoft.com calendars.read is used to request permission to read user's calendar. An app most commonly requests these permissions by specifying the scopes in requests to Microsoft Identity Platform authorized endpoint. However, some high privilege permissions can be granted only through administrator. They can be requested or granted by using the administrator consent endpoint. Yeah. There are multiple endpoints. In requests to the authorization token, token or consent endpoints for the Microsoft Identity Platform, if the resource identifier is omitted in the scope parameter, the resource is assumed to be Microsoft Graph. If the resource identifier is omitted, okay. For example, scope user.read is equivalent to graph Microsoft.com user read. Okay. Permission types. Delegated access and app only access. Okay, after reading this, one question arises in my mind, which is, how we can register the applications. Then in the Microsoft, so that they can be used as APIs and can be represented or can be listed in the permissions, among the permissions chart or register or discovery. Yeah. Okay. In requests to the authorization token or consent endpoints for Microsoft Identity Platform, if the resource identifier is omitted, yeah, we got this one. Permission types. Delegated access are used by apps that have a signed-in user present. For these apps, either the user or an administrator consents to the applications that the app requests. The app is delegated with the permission to act as a signed-in user when it makes calls to the target resource. Okay, permission types. Delegated access on behalf of the user, consented by user or admin, right? The other one, app only access permissions. App only access permissions. What is that? Are used by apps that run without a signed-in user present. Okay, the background, the applications. Okay, these are another the end user, but these are some services or scripts or stuff like that. Apps that run as background services or daemons, only an administrator can consent to app only access permission. Okay, app only access. Only an administrator, admin consent. Consent types. Application in Azure Identity Platform rely on consent in order to gain access to necessary resources or APIs. There are many kinds of consent that your app might need to know about in order to be successful. Applications in Microsoft Identity Platform rely on consent. Yes, we know that. In order to gain access to necessary resources. Yes, there are many kinds of consent that your application might need to know about in order to be successful. If you are defining permissions, you will also need to understand how your users gain access to your app or API. If you are defining permissions, I wish I could again, but I don't know how to. You will also need to understand, okay, how your users gain access to your app or API. There are 3 consent types: static user consent, incremental and dynamic user consent, and admin consent. Permission types, consent types. First, static user consent, incremental and dynamic user consent, and admin consent. I thought it's only admin and user, but user have two different consent type: static and dynamic. Static user consent. How to read this?
Consent.
Consent. In the static user consent scenario, you must specify all the permissions. It needs the application's configuration in the Azure portal. If the user or admin is appropriate hasn't granted consent for this app, then Microsoft Identity Platform prompts the user to provide consent at this time. Static permissions. Then Microsoft Identity Platform prompts the user to provide consent at this time. Static permissions also enable administrator to consent on behalf of all users in the organization. Okay. The admin can do it for all users. While static permissions of the app defined in the Azure portal keep the code nice and simple, it presents some possible issues for developers. The app needs to request all the permissions it would ever need upon the user's first sign-in. This can lead to a long list of permissions that discourages end users from approving the app's access on initial sign-in. The app needs to know all of the resources if it would ever access ahead of time. It's difficult to create apps that could access an arbitrary number of resources. Incremental and dynamic user consent.
Consent.
With Microsoft Identity Platform endpoint, you can ignore the static permission defined in the application registration information port in the portal and the request permissions incrementally instead. You can ask for a minimum set of permissions upfront and request more over time as the customer uses more app features. To do so, you can specify the scopes your app needs at any time by including the new scopes in the scope parameter when requesting an access token. Easy. When you are requesting an access token, anytime include the new scopes in the scope parameter without the need to redefine them in the application registration information. If the user hasn't yet consented to new scopes added to the request, they are prompted to consent only to the new permissions. Incremental or dynamic consent only applies to delegated permissions and not to app-only access permissions. Makes sense. App-only access permissions are still static then. Important. Dynamic consent can be convenient, but represents a big challenge for permissions that require admin consent. Since the admin consent experience doesn't know about those permissions at consent time, if you require admin privileged permissions or if your app uses dynamic consent, you must register all of the permissions in the Azure portal, not just the subset of permissions that require admin consent. This enables tenant admins to consent on behalf of all their users. I'm missing something. I couldn't place it in my mind. Okay, dynamic consent can be convenient, but represents a big challenge for permissions that require admin consent. Okay, if they require admin consent, we cannot ask them incrementally, since the admin consent experience doesn't know about those permissions at consent time. If you require admin privilege permissions, or if you add uses dynamic consent, if your app uses dynamic consent, you must register. All of the permissions in the Azure portal. Or if you require admin privilege permissions, or if your app uses dynamic consent. Yeah, of course it uses dynamic consent. Why do I need to register all the permissions in the Azure portal, not just subset of permissions that require admin consent? Okay. If you require admin privilege permissions. Okay, I got it. If you include some permissions which require admin privilege, then you have to add everything in the portal. Okay. Admin consent. But it can be forgettable. It is forgettable. Admin consent, the last one, is required when your app needs access to certain high privilege permissions. Admin consent ensures that administrators have some other controls before authorizing apps or users to access highly privileged data from the organization. Let's read again. Admin consent is required when your app needs access to certain high privilege permissions. Admin consent ensures that administrators have some other control before authorizing apps or users to access highly privileged data from the organization. Okay. Yeah, you want to be in charge, you want to be in control. So you want to first consent, then users can do later. Admin consent done on behalf of an organization still requires the static permissions registered for the app. Set those permissions for apps in the app registration portal if you need an admin to give consent on behalf of the entire organization. This reduces the cycles required by the organization application requesting individual user consent. In an OpenID Connect or through authorization request, an app can request the permissions it needs by using the scope query parameter. For example, when a user is signing in to an application, the app sends a request like following example. Line breaks are added for legibility. Get, authorize, client ID, yes, response, redirect, scope. The scope parameter is a space-separated list of delegated permissions. Space-separated. Interesting. That app is requesting. Each permission is indicated by appending the permission value to the resources identifier. In the required example, the app needs permission to read. After the user enters their credentials, the Microsoft Identity Platform checks for a matching record of user consent. If the user hasn't consented to any of the requested permissions in the past, and if the administrator hasn't consented to those permissions on behalf of the entire organization, the Microsoft Identity Platform asks the user to grant the requested permissions. Very good. Discover conditional access. This is the last one before section exam. The conditional access feature in Microsoft Entra ID offers one of several ways that you can use to secure your app and protect as a service. Conditional access enables developers and enterprise customers to protect services in multitude of ways, including multi-factor authentication. Multi-factor authentication, yeah, MFA. Conditional access, huh? Allowing only Intune enrolled devices to access specific services. Very good. Restricting user locations and IP ranges. Yeah, makes sense. How does conditional access impact an app? In most common cases, conditional access doesn't change an app's behavior. or require any changes from developer. Okay. Only in certain cases, when application indirectly or silently requests a token for a service, does an app require code changes to handle conditional access challenges. It may be as simple as performing an interactive sign-in request. Especially the following scenarios require code to handle conditional access challenges. Apps performing on behalf of flow. Yes, the normal website flow, I think. Apps accessing multiple services, resources. Single page apps using MAS.js. Web apps calling a resource. Conditional access policies can be applied to the app and also web API your app accesses. Conditional access policies can be applied to the app and also a web API your app accesses. Why? My app and the API my app call. Okay, accesses. Depending on the scenario, an enterprise customer can apply and remove conditional access policies at any time. Enterprise customer can apply or remove condition for your app to continue functioning when a new policy is applied. Implement challenge handling. Examples. Some scenarios require code changes to handle conditional access, whereas others work as is. Here are a few scenarios using conditional access to do multi-factor authentication that gives some insight into difference. You are building a single tenant iOS app and apply a conditional access policy. The app signs in a user and doesn't request access to an API. When the user signs in, the policy is automatically invoked and the user needs to perform multi-factor authentication. When the user signs in, the policy is automatically invoked. You are building an app that uses middle tier service to access a downstream API, and the enterprise customer at the company using this API applies a policy to the downstream API. When an end user signs in, the app requests access to the middle tier and sends the token. The middle tier performs on behalf of flow to request access to the downstream API. At this point, the claim challenge is represented to the middle tier. The middle tier sends the challenge back to the app, which needs to comply with the conditional access policy. I think let's skip and save notes. Which of the types of permissions supported by Microsoft Identity Platform is used by apps that have a signed-in user present? Types of permissions supported by Microsoft Platform used by apps that have a signed-in user present. That have a signed-in user. Okay. The end user, I think app only, no. Delegated, yes, put delegated and app only, no, delegated. Which of the following app scenarios require code to handle conditional access challenges? Which of the following app scenarios require code to handle conditional access challenges? This can be my first wrong answer. Apps performing device code flow, apps performing on behalf of flow, apps performing the integrated Windows authentication flow. Nobody talked about device code flow. Probably that is require code to which of the following app scenarios require code to handle conditional access challenges? Correct. Yeah, I couldn't understand exactly in this part, I think. Apps performing on behalf of flow. Apps accessing multi-service resources. Single app using. No, I'm gonna try more. I'm gonna read more, but yeah, let's continue later with second topic. Implement authentication by using the Microsoft Authentication library in the next part. See ya.